talk about the universe. In the beginning, the astronomers had to believe that because is in ancient time, I think before just 100 years, the the hypothesis about the universe was that the universe is static and it before existed and that was never created and never dominated. That was just as it is. That remained. Nobody knew about this. How the universe actually was.
And there is the field equation from Einstein. And the equation is actually telling about the universe is actually accelerating. But during that time, there was the assumptions among the astronomers that the universe is static. So here G mu is equals to R mu V minus 1 half G mu V R equals to 8 pi G T mu V upon C to the 4 minus G mu V omega, where that omega is cosmological constant, which in the present time is dark energy. So the time and the radius of curvature of space-time is like that. The graph time and curvature radius graph is this. The cosmological constants has two effects. The omega cosmological constant has two effects: anti-gravity effect and density increase effect. Whereas the anti-gravity effect is derived from the Hubble constant, and equation is Friedmann equation, which is following like this: the rho, pressure, and the omega, and the density increase effect K, the curvature, omega dark energy, and rho energy density of matter.
Einstein gave a new model based on the gravity and the cosmological structure of the space-time. So, according to his model, actually the universe is collapsing. The entire mass of the universe is collapsing into the center of the universe. So, but what happens? The astronomers did not believe him, and thus, so many astronomers they did not believe him. Then Einstein thought that I think this universe should be static. If the whole matter is falling into the center, then the universe must be destroyed. But that's not happening. He added cosmological constant to stop the anti-gravity, to stop the gravitational pull at the center, to balance. Something that opposing the gravity, pushing the mass at the center, anti-gravity. There must be some external field, external properties inside the field of matter and energy, which is just stopping the matter falling into the center, which is just behaving like anti-gravity. So he added a cosmological constant thus in his equations, the field equation, and that cosmological constant actually did not work during that time. is the Edwin Hubble's experiments and his observations. Just he observed that the universe was expanding rather than falling into the center. This is static. Then Einstein was in the big trouble. He just called his cosmological constant a blunder. Then he removed from his equations, and that was confirmed by Edwin Hubble. The universe is actually expanding, and the expansion rate was just by, according to the Hubble's constant, the present value of Hubble constant is 72, around 72. It varies with the time. It's a variable thing, but mostly confirmed value is 72 per kilometer per megaparsec is the current value. And after that, Einstein removed his cosmological constant, and now we confirm that the universe is expanding. But what about the expansion rate? Expansion rate is accelerating or deaccelerating. This is the scenario. And the acceleration and deacceleration is actually acceleration and deacceleration is actually there. A property of cosmological constant that Einstein added in his equation. So this is the scenario. Is the Hubble constant is telling about the expansion rate is fluctuating, sometimes increasing. Data tells that increasing or decreasing. So this value is actually a property of cosmological constant. The cosmological constant theory came from that idea that if the universe is expanding, then this should have it should have been started from a single tiny infinitesimal mass and singularity. So the Big Bang model came into the play, and the scientists, cosmologists, and the astronomers started working on that. The estimated value of Big Bang model. The Big Bang model was not confirmed experimentally during that time, but this time there are so many data that confirm that the Big Bang theory is true, or this is really happened in just 13.7 billion years ago. The calculated value is 13.7 billion years ago. So, according to the Big Bang theory, in the beginning there was nothing, there was a singularity, and just what happens, there was the entire mass of the universe was in the central, in a tiny area. There was huge density, the temperature was very hot, and due to the high fluctuations, the quantum fluctuations, the singularity is breaking, that explodes, which causes the gravity is losing its potential. The gravity is dominated. The gravity loses its control over the singularity, and each matter expands. Universe expands. The radiations, the matters, expands in a high temperature, and that forms the particles, photons, many bosons, gluons, neutrinos, and the neutron couplings electron formations, quark formations, particle antiparticle formations actually began. That was the nucleosynthesis after the explosion of singularity. And as the temperatures fall down, the matter expands. The particles started coupling to each other. They started forming the protons, neutrons, hadrons. That was the baryonic, the lithiums, and baryons. Many heavier atoms were formed, and that forms see that the present universe is exactly is a baryonic matter due to the baryosynthesis process during the Big Bang happened in the 13.7 billion year ago. It's up there. You can find out the data is collected by the scientists, and these data are supporting to the Big Bang theory. And the theory is actually correct because many theories supporting to this model. And now after the 13.7, now we are in just present time. We've been calculating the radiations, the percentage of radiations, the presence of radiations occurred in the Big Bang period. During the Big Bang, the extra matter and the extra energy and the presence of baryonic matter. The scientists are confirming that the dark matter is 24%, dark energy is 72%, which is a form of the cosmological constant given by Albert Einstein, and just only 4% is baryonic matter. Why only the 4% baryonic matter? There is a theory. And the problem is that there is no experimental verification of these matter dominations, dark energy, and dark matter presence in the universe. But now, the data collected from the CMB, cosmic microwave background radiations, the 3 sigma and 5 sigma models tells that the presence of the dark energy and dark matter is exactly the true thing, and how much percent of each matter and energy and baryonic matter is present in the universe is actually confirmed. And now this confirmation of the presence of the dark matter and dark energy and baryonic matter is a Nobel Prize winning research, a model which is actually providing a Nobel Prize to the scientist. And who is the scientist and what is that model? You will see in the next video. And we will discuss about how the matter exists, dark energy, dark matter, baryonic matter percentage in the universe, how this is confirmed, what is the true place of these energy matter presence in the universe. We will see in the next